Now that we are showtime, we are going to be talking about open source testing. This is a topic which we have been talking on the storage side of the world for quite some time. And we wanted to bring more details on this topic in this forum, which is probably more focused on designing the frameworks as well as designing open source tools for the industry in there. The slides what we walk through are somewhere kind of showing the problems what we have faced in our qualification process. These problems kind of were partly discovered on the storage side of the things, but pretty much applies to any qualification of any components which we do at Meta. So I'm Vineet Parekh. I'm a hardware systems engineer at Meta, and I have my co-presenter Jan, who is part of the same team. So we started with this thought process in terms of, what would happen if we actually had a world where we had, open source testing, becomes an innovation and a cornerstone for like seamless and efficient qual. But the reason we came up with this imagination was, our qualification process started becoming a long pole for many components, and who likes having a lengthy qualification? It's a loss for the vendors. It's a loss for the hyperscalers. The current state of SSD qualification, again, SSD, for those who are not from storage background, is a flash device. It's a solid state drive. That's what it stands for. We had diverse approaches. Every hyperscaler would have its own type of tool, which it would provide to a particular vendor, which would go ahead and do a qualification of that. So it may be Meta or any other hyperscaler. They all had custom tools. We at Meta used to give something which we call as hi-fi out there. The vendors would probably face a lot of challenges in terms of integration of this particular framework. It required extensive support to do that. You have to invest in a lot of like physical and space as well as human resources to go ahead and run some of these qualifications. And those became a big issue too, because when you have these custom solutions which you're supporting, you're going to find issues. Nothing's going to run smooth. And so how do you basically work with all the customers plus the vendors, finding all these different types of issues and kind of support them on a day-to-day basis? So it became heavy for us to kind of support that too, because you have, if across SSD, plus if you multiply that with different components and the number of vendors in the industry, it was not efficient for us to support that. Our solution to that was open sourcing our tests. What we started doing was not just open sourcing our tests, but open sourcing our framework on how we write tests too. And Jan will probably cover much more in detail about how we do that, what are the different components, and kind of give you guys a bit preview about it. We thought this would, some of the hypothesis we laid out was that it'll actually reduce a lot of complexity and the cost. If you put the code out there in open source and it's like visible code which people can download, run, debug, can add to and find issues to, over a period of time you get more used to using it and kind of get familiar with it, and complexity reduces, and so as cost. Accelerated innovation was one of our things too, because a lot of the qualification frameworks and tools which we used to give to vendors, they would only be able to run in a certain stage of their qual. Okay, they would only be able to run in a certain stage of their qual cycle, and we wanted them to actually run much earlier. So if we share tests with you, which could be actually run much earlier in your design cycle, and get ready for the actual qual, that would help in faster innovation. Was our thesis. And you know what? We started with this imagination slide, and that was where we were like around this beginning of the year. And this May, we actually went ahead and launched our framework as well as our first set of tests in there. And we chose the OCP test and validation as our medium to bring this out, because there's a lot of work which is done in OCP with respect OCP test and validation initiative with respect to OCP diagnostics, as well as modifying the tool to support OCP diag, and Jan will probably get into some of this in there. So the OCP framework and the storage test repositories are readily available on the GitHub links which I shared out there. And what we do over here is we separate into two different repositories, and you might ask why we do that. But the OCP test framework is more of our Meta's methodology of how we are trying to write. It's nothing novel about it. It's basically any standard Python way of going and create an object-oriented based test repository. The framework will allow people to enable and write tests for not just like storage components, but for many other components. And we don't have any hard announcements, but we've already been starting to work on as we are kind of finishing storage into the next set of components. So it could be network, DRAM, GPU, all of those tests. So we plan to open source everything what we have. Okay, I'll let Jan continue and give you guys more details about our framework as well as how it is structured.
Yeah, thanks a lot, Vineet. So Vineet talked a little bit about how we landed here, how we kind of from, sorry, this is working, from historic versions of our qualification process landed at an open source solution. So we announced this earlier this year in around May timeframe. These repositories are available right now, so you can go to GitHub and see the code right over there. But since then, we also have made some changes. So I will go into a little bit of detail of what these framework and test cases actually contain. And then, yeah, after that, I please invite everybody to take a look at the code and play around with it. We're really looking at community contributions here. So Vineet was talking a little bit about that we actually have two repositories here. We have a framework and orchestrator as a separate repository, and then we have our SSD test cases and shared libraries as a separate repository. And the reason behind that is that this framework that we're releasing here, the AutoVal framework, internally at Meta, we use that for all types of hardware validation, for all types of platforms. But we are at this point right now only open sourcing our SSD qualification test cases. So we're holding open the option in the future to release additional test cases and test libraries. We're not announcing anything here right now, but that is part of the reason on why we have a separation there. The framework is usable also for tests that are non-SSD specific. So that's the reason for the two separate frameworks. And then on top of that, the one thing that we're also announcing here is that the framework is now integrated with the OCB diag output format. So there are multiple additional talks, I think also later today, on what this diag format actually contains of and some of the additional benefits of open source enablement here. What we are doing is, as part of this framework, we are automatically generating OCB diag compliant output. So that gives you, as a user with an existing framework, an easy way of integrating it into your environment. Okay, so yeah, I'm just very quickly going to go a little bit about what we actually mean with an AutoVal framework and orchestrator. So pretty much this framework is responsible for taking some user input and then generating output back to the user. So the user input is pretty much two types of input. It's host information, like which device under test you want to run against. This can be one or more systems. So you pass in information like the IP, BMC IP, and so on to log into that system. And then you also pass in some parameters for your test case. So these test cases that we're releasing, they are parameterized. So you can have different combinations of the same test module with different parameters. As output, I was already referring to the OCP diag compliant output. So this output format contains information like test step, pass-fail data. It has host configuration data, so that later on you can run some analytics on which hardware, firmware, software combination you actually ran the tests against. And it also includes parametric data, like performance data, for example, that's collected by your test cases. So you can run this as either a single test case or a test suite, in which case you can pass in multiple tests and parameters, and then our orchestrator will be responsible for orchestrating the execution of these test cases in the order that you specified. And this is our approach to the joint qualification. So we're giving these out to our vendor partners, and this is our test suite for SSD qualifications. If we get the output of that, we have a pretty good understanding of the state of that hardware, firmware, software combination. So also the AutoVal framework itself comes with some shared libraries. Again, I invite everybody to take a look at the GitHub repository. There's a lot of common code in there for logging, for actual handling the connections to the device under test, for error handling, to control the execution flow, and so on. Some context of the environment that we're running in. So this is, AutoVal is developed for a Linux environment. We are recommending CentOS, but don't necessarily have a strict requirement on CentOS. But that is the closest one where we can guarantee that it should work as is without any additional modifications. Then typically the way our execution works is you're running the test from a controller host, and from that controller host we will open SSH connections to communicate between that controller and the device under test and the BMC to execute the commands and get the results of the test case. All right, some additional AutoVal features. I think these are relatively standard test framework features, but I want to reference them here to give a little bit of a background on how we're developing this framework. So every test case that is developed using the AutoVal framework goes through a test life cycle, which is pretty much just a sequence of stages that each test case operates through. So there's a setup stage, an execution phase, and a cleanup phase. During setup, the framework itself will do some initialization, like initialize log directories, verifies that the connection to the DOT is actually successful, and so on. Then the execution phase is the one where the majority of the test logic actually lives. So this is where, when developing new test cases, you would have some validation steps to verify that actually your test case is successful, or fail if not, obviously. And then during cleanup, we clean up the environment, archive the log content, and bring the system back into a kind of fresh state. So one other thing specific to AutoVal here that I want to mention are our validation methods. If you're familiar with other test frameworks, they are very similar to assert methods. It's pretty much a check as part of your test case that it's progressing in a manner as expected, as intended by the test. And each test should have at least one, but ideally multiple of these validation steps. So you can think about it, it's either a simple check that something is true or false, that the output is valid of some operation, of some command that you're running, or that you're running, let's say if you have a less or greater comparison, that you have some valid performance results coming out of your test cases. So the bunch of test cases that we're actually releasing right now, I was referring to as the kind of qualification for SSD drive test cases. You can see them here on the left side. I'm not going to go into all detail about them, but maybe at a high level, I will talk a little bit about what the content of these test cases is. So you can think of it in kind of 2 or 3 different ways. There are some general storage workloads that we're running, usually using the FIO tool. You can see there's the FIO, Thins, Flash, and some other test cases for that. There are also some drive feature test cases, like drive data integrity tests and so on, and then some NVMe compatibility test cases. Each of these test cases contains of multiple separate steps. So you can think of it in some way already as a test case already being like a test suite responsible for validating a specific area of the drive. For example, our data integrity test will go through multiple steps to validate the data integrity across power cycles of the SSD drives. And then the way these test cases are implemented, and what is also available as part of the open source release here, is through shared libraries. So you can see those on the right-hand side here, actually. So there are different libraries for different types of drives, for different interaction with the system, like PCI utils and so on, for interacting with the file system, with a disk, some libraries on utilizing FIO, for example, since I mentioned that's what a lot of our tests are doing. And again, I'm not going to go into all the details here, but I would really invite you to take a look at this. There's also one very basic test case, like a connect test case that we recently released that allows you to just see a very simple way of an AutoVal test case, and it would allow you to build on top of that. So this is some sample code here. You can see, previously mentioned, there's an execution phase for each test case. So this is, on the left-hand side, you can see we're getting some parameters from a test control file. And then what we're doing is we're running multiple cycles, multiple iterations of an FIO workload while triggering a power cycle on the system, and then validating the system integrity after these power cycles. On the right-hand side, you can see the parameters that are being passed in here. You can see in this example, we're doing a warm power cycle and a specific workload that we're using, like different block size, runtime, and so on. So this is how test cases in AutoVal are being parameterized. You can now think about, you can have different combinations of these parameters to test all kinds of combinations of a test case here. And then on the bottom left, you can see how you run this. The AutoVal test runner, this is the orchestrator that I was referring to before. You pass in the test that you want to run, the configuration file that you want to use for this, and then the host information, like the IP of the DOT that you want to connect to. So if you run this, then like I already mentioned before, what this will automatically do now is it will generate OCP DIG compliant output. I have a small kind of sample size here on the top of what is happening. You can see the yellow highlighted portion. That's pretty much from the previous slide, the validation that we did there. And in case that this is successful, then AutoVal will automatically generate this as a passed test step using this OCP-like compliant output. So this output is generated for you automatically. You don't really have to do anything to get this output if you use the AutoVal libraries. And the benefit, I was talking a little bit about this before, is we now have a standardized spec here that we can use for this diagnostic and test output. So not only AutoVal uses this output, but other frameworks that are already existing or that are being developed right now are also using this spec, and that allows for easier interoperability and integration of AutoVal output into these frameworks. And yeah, again, I think the OCP-like format, this is only a small subset of it, but includes things like pass-fail information, system configuration information, and performance metrics that are collected as part of your output. Yeah, and I think with that, I will hand back to Vineet for some call to action here.
Sure. Thanks, Jan. So, where do we go from here? What's the impact and future benefits of directions which we are trying to take here? We believe that implementing this open source test cases and kind of going in this journey is going to have industry-wide benefits. It's not just related to storage, as Jan probably said, although what we have outside is storage. So we encourage everybody who is probably in this space to kind of have a look at it and comment if you guys have any feedback. This is much more scalable in nature than the customized approach what we had before, where every vendor had their own set of tests and frameworks. What we have out there, having it in open source, of course, has the advantage of scaling it to the extent what we want. And I guess it probably encourages more collaborative, which is probably what in the spirit of what OCP is all about, is coming together to solve a very complex problem and having some wins in our qualification cycles. And our call to action, so we invite all the industry players to come join. There's a OCP test and validation work group. You guys are welcome to come join and be part of that. Provide your ideas and feedback in terms of how we can improve the overall OCP diag plus the open source testing framework. Reach out to me or Jan if you guys have any questions about the two repositories, what we already have out there. Feel free to do that. Give it a try. If you are probably somewhere who doing tests or probably planning to do that in your qual cycles, give it a try. It should work. So, and hopefully we start this new world where our qualification tests as procedures are much more open source, and we can probably be much more efficient in this process. So thank you. Yes, I think we have 3 minutes for questions, but don't have a moderator, so it's tough to decide. Okay, cool. We're done. Thank you.